it works really well. This idea of putting the air down around the sides and pulling it up through the center, exactly the opposite of what you would do in a surgical theater. I mean, it's just absolutely not what you do in what I would call sort of the second most controlled space that you might typically find. So if you walk through the city of Chicago, it's going to be laser labs and surgical theaters where people think about this type of cleanliness, clean rooms as well. But it's just the opposite model from what most people do, but it keeps the bottom skin and top skin of that table exactly in tune, so you really get excellent performance. And it also means that your heat-producing equipment that you set up on this laser rack right here, the heat just gets pulled off. So you turn on an extra oscilloscope or something, and you're not blowing that change in heat right down onto your laser table, which is very important, because when you're working in these labs, as compared to telling people to get out of the way from a photo that I took, probably was a mistake, when you're working, you're turning stuff on and off. There are changes that are happening above the table with monitoring equipment. You have people coming in and out. You really want to try and isolate your table from all of those different things. This airflow does that very, very well while maintaining a clean environment. So this is the basic structure of the lab. The way we got here, thinking about the innovation, thinking about clever solutions, thinking about how we would actually arrange furniture in the lab. I didn't expect that my HVAC team was going to tell me where and how to place my laser table and which shape it should be and which way it should face in the space. I mean, that wasn't sort of inside the envelope of what I considered HVAC. On the other hand, it was absolutely crucial to design the system to exactly match the placement. So just knowing that up front, so we're considering the right things in the right order, is extremely critical to success of this project. Also compromises. Everything in science is a compromise. Anytime you try to do something well, it means you're not paying attention to something else. There's always this aspect of where you spend your time and how you optimize. I didn't quite understand when I was coming in and making demands about a lab that there are, of course, compromises in every other domain as well. I mean, I really can be that ivory tower academic with the blinders on. Frankly, it's kind of fun sometimes. But there are a lot of compromises that go in. If you do something, what else do you give up? If you really care about temperature and humidity, how much are you willing to give on, say, a dust specification or on vibration? These things matter. And so understanding where the soft points are. Not every laser lab has exactly the same needs. Sometimes, if you're not ultra fast, you don't care as much about the humidity. Just below 45% will be fine, but 30% is the same as 38%. It's no problem at all. If you really care about those timings, then suddenly it puts a really tight control band on that. So being able to talk to people about what you really need, as compared to say, hey, just make a copy of that, can really change the costs. And we've had a number of people come into our building who have taken this type of thing as a base system and said, yeah, I don't need this, but I need that. I really care about magnetics. I really care about temperature, but not humidity. How can we do this? Can we zone it differently? I want more small experiments, not one big experiment. My experiments are naturally small, and his are huge, but it doesn't really matter. So thinking about how you might do this is important. So different people have different needs. And that's something else that really became clear in this process. And it's one of the reasons why I've liked working with this team. The other thing, of course, which I think to answer some of the questions, which would be inevitable at this point, is how does it work? So when you go into this space and you work on it, what type of performance can you actually expect in the laser lab?